Hi guys, so this video is going to focus on word problems using law of sines or cosines. Um, so the first one says the sides of a parallelogram are 39 and 41.5 meters long. The measure of one angle in the parallelogram is 58. Okay, so I'm going to make this one 39, this one 41.5. Just based off of the look of how I made this, let's make this one 58. That one's more cute than that guy. Now, find the length of the diagonals. A couple things, though, that you have to remember about parallelograms. So if this is 39, so is this. If this is 41.5, so is this. These two angles would be supplements. So this would be 122, 58, 122. Okay, so I'm going to start with one of the diagonals. Now, it wants both. I'm just going to start with one at a time. So if I put in this one, let's call that diagonal 1. Okay, and I want to find the length of that. Okay, so this is going to be, if we have a side and angle aside, this is going to use the law of cosines. So I'm going to call that the side that I'm looking for, that d1 squared, right? And I have the angle across from it, so that's good. That'll be the angle that'll go with the cosine. So then I have the other two side lengths, so 39 squared plus 41.5 squared minus 2, because if you think of this as like c squared equals a squared plus b squared minus 2ab, so minus 2 times 39 times 41.5 cosine of the angle across from that d1 side, so 122 degrees. Now, this is one where you can enter this whole right-hand side straight into the calculator, square root that, and you'll get that the diagonal is 39.1 meters. Okay. Now, we need to find the other diagonal as well. So let's call this guy D2. Okay. So now I'm going to look at this triangle. Okay. So just so you can be clear on what I'm looking at, I'll just draw a small sketch here. So you can see that this is 58, 41.5, 39. Okay, so very similar. So the G2 squared, right, is equal to, these are the A and B, if you will. So 39 squared plus 41.5 squared minus 2 times 39 times 41.5. But now the angle across from that diagonal is now cosine of 58 degrees. Oops, it looks like I wrote these answers backwards. So sorry. This one should have been 70.4. My bad. I have them flipped on my paper. So this one, when you enter this in the calculator, square root that, you get that this guy is 39.1 meters. Sorry about that. Okay? So nothing crazy there. You just got to make sure that you set up and put the right angle in for the right diagonal. Okay, a plane flies at a bearing of 31 degrees. So let's put in our vertical dash line for bearing. So 31 degrees. Now, there's no north, south, east, west. So that's just from due north. That's your traditional bearing. So like 31 degrees for 210 miles. It then turns. So let's put in our next dash line. Now, you need to have appropriate pictures for all of these. At a bearing of 143 degrees. So once again, there's no north, south, east, west. So that's from due north, so 143 degrees. That would be 90, so like this, 143 degrees. Now, if this is 210 and it's going for 350, let's make that bigger. Okay. How far is the plane from its origin? So where it started, I'm going to make this a little bit shorter. Okay. So, my goodness. We can't do Pythagorean theorem because we're not guaranteed that we have a right angle. So let's move some values around. So if this is 31 degrees, this is 31 degrees. And you need to label these pieces. If this is a straight line and this is 143, this side is 37 degrees. Okay, so that whole angle would be 68 degrees. So from here, we want to find the missing side. So how far is the plane from its origin? So if you think about this, we have a side, this whole angle, and a side. So for the first question there, we have a side angle side, so we can do law of cosines. Okay? So if I do c squared equals a squared plus b squared minus 2ab cosine c. Okay, I'm going to call this side my c. Doesn't matter which of these is your a or b. So c squared equals 210 squared plus 350 squared minus 2 times 210 times 350, and then cosine of the angle across from C, that whole angle, which is 68 degrees. You can enter that whole thing in, square root it, and you should get that C, I got 333.97, so approximately 334 miles. Okay. Now the next part, we want to know the bearing the plane needs to turn to go home. So let's put in our vertical dashed line here. Okay. Now, for this, you either need to do it from due north all the way around, or if you're doing directional bearing, it has to be between 0 and 90. A lot of you screwed that up on the last test. Directional bearing, if you're using the whole north, south, east, west, has to be between 0 and 90. So let's start by finding this angle. So if you think about this, I need this angle, and I have a side across from it, and then I need a pair of angle and side lengths that go together, so I could use this and this at this point because I don't have this pair. So let's do sine of 68 over that 334 equals sine of theta, and please label on your picture so I know what angle you're finding. Okay, sine of theta equals, divided by 210. So when I cross multiply and solve for that, I get that theta is 35.7 degrees. So this whole angle right here, is 35.7 degrees. Okay, but for the bearing, it has to come from the vertical. So, and it has to be between 0 and 90 if I'm going to do the whole north, south, east, west. So let's move some other values around. So if this is a vertical dashed line and so is this, if this portion right here is 37, this little portion right here is 37, then so is this portion. So if I add those together, so 35.7 plus 37, that equals 72.7, which is between 0 and 90, so that's good. And that's from the north side, but on the west. Okay? After this, you're going to have a couple practice problems with word problems. Next week, we will do some more word problems practice and review for the test. Please, please, please reach out if you have any questions or need any help. Thanks, guys.